The tale of your effect on man is a long one. But what we're interested in is the why and how of your activities, the truth about the weather.
Truth? You guys calling me a liar when I say I blow to please Meteora?
That's not why you blow, Windy.
Windy?
No, it isn't. The real cause of wind is the sun.
Here, I'll show you. Jim, let's have roll 2, general circulation.
Coming right up.
Now, anybody who's ever lived in the tropics knows that around the equator, the Earth is like a stove, heated by the sun year in and year out. And over this giant stove, warm air is constantly rising. But near the poles, the Earth's like a cake of ice, frozen year-round. And over the poles, cool air is constantly falling. Now, watch what comes out of this up and down air. The cold air moves toward the equator to replace the rising warm air, and the warm air moves high up toward the poles to replace the sinking cold air. Two big loops of north and south winds encircling the Earth.
And that is wind?
What's more, they keep the earth green and warm, bringing rain from the oceans and heat from the tropics. If the sun were to fail, all the winds of the world would die away in a few weeks, and our planet would be finished.
Now, wait a minute. Everybody knows I don't just blow up and down and north and south. I blow east and west, too.
Sure, but I'll give you odds you don't know why.
Why? Why, because of Meteora.
Windy. Meteora's not the answer.
Do you know the answer?
Well, I got a friend who does. Like to drop in on a carnival and meet him?
A carnival?
They've lost their mind.
Oh, carnival? Oh, I like carnivals.
That carnival belongs to my friend, Professor Coriolis. And that's his carousel. Oh, Professor.
A moment, please. I am at your service. 2 tickets? No?
No tickets, not today.
Tomorrow, maybe?
Well, maybe. What we're interested in right now, Professor, would you explain to us why wind blows east and west as well as north and south?
With pleasure. To show this, I must use the carousel. Attention! Now you must get on the carousel with the children. Now I give one child a ball. So, easy, no? But see what happens when I start the carousel? Pierre. Now.
But the ball curved.
Naturally. Now let us watch the same action once more, only this time we slow everything down. Missed again.
You see? It did curve.
Aha! You think so? Come, we find out. But this time we must get off the happy-go-round. Now we observe the exact same throw once more. Pierre, whoop! It never curved at all, did it?
I don't believe it.
What happens is I show you very, very slow. The catcher is moving with the carousel. So the ball missed him. But remember, when you were on the carousel, it looked like this.
I begin to see. When you're on the carousel, it seems to curve. When you're off it, it doesn't.
That's right, that's right. And now I take you to the biggest carousel of all, the spinning Earth. If we take the part north of the equator, and tilt it a little, we have a carousel which turns counterclockwise to the left. So for you on this carousel, like the little boy on the happy-go-round, everything curves to the right in the northern hemisphere. You do not believe me? Eh bien, suppose, please, that I am on the North Pole. I am lonely, and I wish very much to see in New York my friend Fifi. Coming, Fifi! Ah, no!
As the professor found out, to someone on Earth unaware of its motion, the rocket will curve to the right.
But to someone out in space who can tell the Earth is rotating, this is what it looks like. The rocket goes straight, but the Earth is spinning. But since we're not in space, for us in the northern hemisphere, there's this curve to the right for anything that moves. Gunners must adjust for this apparent curve. Transatlantic planes would get lost if their navigators didn't correct for the effect. Even migrating birds have some mysterious built-in mechanism which corrects for it. And so you see...
Pardon, messieurs. You have overlooked the best example of the drift to the right. The wind. This whole affair is called the coriolis effect. Merci bien. I trust I have made all this quite clear. Au revoir, mes amis.
Well, if it isn't quite clear, let's examine our wind loop again. See what happens when the Earth begins to make like the professor's happy-go-round. The big loop becomes 3 smaller loops. Now, so we can look at them, I bring the carousel to a stop just like the professor. This loop by the equator is just a smaller version of our original one. But the southbound air close to the ground, swung to its right by Coriolis, begins to blow from the east. Isn't that about it, Doc?
Yes, that's right. Creating the trade winds that sailors used for centuries to circle the globe.
Now, loop number 2. Here the air near the ground moves north because... Doc, maybe you better take over, huh?
Well, this reverse loop hasn't been completely explained, but it's easy to see that lateral friction due to large-scale turbulence, the transport of angular momentum, conservation of potential vorticity, as well as baroclinicity in the frontal zone.
Doc, let's just say the loop is there, huh? And that the northbound air near the ground is swung to its right and begins to blow from the west,
creating the prevailing westerlies.
And finally, the cold sinking air in the third loop, equator-bound, is swung to its right to become the polar easterlies. There you have it, folks, from the Coriolis merry-go-round to the general circulation of the atmosphere.
And this is actually how wind is made?
Well, yes. In general, wind is created by the sun and given direction by the Coriolis effect.